Hi, welcome to the brand new section of the course, ForkJoin Framework. This section presents 5 videos that show you how to work efficiently with the ForkJoin framework. We will begin with creating ForkJoinPool and joining the results of the tasks. Then we will run several tasks asynchronously. Further execution may throw the exceptions in the tasks. Lastly, we will learn to cancel a task. Now we move on to the first video of this section that deals with creating a ForkJoinPool. In this video, we will create a ForkJoinPool object to execute the tasks and a subclass of ForkJoinTask which will be executed in the pool. Let's take an overview of the main characteristics of the ForkJoin framework. You will create ForkJoinPool using the default constructor. Inside the task, you will use the structure recommended by the Java API documentation. You will execute the tasks in a synchronized way. When a task executes 2 or more subtasks, it waits for their finalizations. In this way, the thread that was executing that task, called worker thread, will look for other tasks to execute, taking full advantage of their execution time. The tasks you're going to implement won't return any result, so you'll take the recursive action class as the base class for their implementation. Let's create a new Java project and give it a name of your choice. Here, we will implement a task to update the price of a list of products. The initial task will be responsible for updating all the elements in a list. So, we start with create a class named product that will store the name and price of a product. Within the product class, we declare a private string attribute named name and also declare a private double attribute named price. Next, we implement getter and setter methods for name and price attribute. So enter these lines of code. Creating a new class named ProductListGenerator to generate a list of random products. Here, we import the ArrayList and list library. Now, we implement the generate method. This method receives an int parameter with the size of the list and returns a list product object with the list of generated products. We create the object to return the list of products. Enter this line of code to generate the list of 10 products. We have assigned same price to all of the products, for example 10, to check that the program works well. In this line, we have assigned the name of the product. Now we create a class named task. Here we specify that it extends the recursive action class. We need to import the list and recursive action library. Also import the product class which we created previously. Within the task class, we declare a private list product attribute named products. Then we also declare 2 private int attributes named first and last with these lines of code. These attributes will determine the block of products that this task has to process. Next, declare a private double attribute named increment to store the increment of the price of the products using this line of code. With this code, we implement the constructor of the class, and this part of the code initializes all the attributes of the class. Now we apply the compute method, which will implement the logic of the task. Post that we check if the difference of the last and first attributes is less than 10. The task has to update the price of less than 10 products. Then increment the price of that set of products using the update prices method. Add the else block. Here it checks if the difference between the last and first attributes is greater than or equal to 10. We create 2 new task objects, one to process the first half of the products and the other to process the second half, and then execute them in ForkJoinPool using the invokeAll method. Moving ahead, we add this block of code to implement the update prices method. This method updates the products that occupy the positions between the values of the first and last attributes in the list of products. Since the task class doesn't return a result, it extends the recursive action class. Here we use the recommended structure for the implementation of the task. If the task has to update more than 10 products, it divides that set of elements into 2 blocks, creates 2 tasks, and assigns a block to each task. We use the first and last attributes in the task class to know the range of positions that this task has to update in the list of products. We use the first and last attributes to use only 1 copy of the product list and not create different lists for each task. To execute the subtasks that the task creates, it calls the invokeAll method. This is a synchronous call, and the task waits for the finalization of the subtasks before continuing, potentially finishing its execution. we use the invokeAll method in the task class, which extends the recursive action class, which in turn extends the ForkJoinTask class. Finally, we create the main class of the program and add the main method to it with this line of code. Here, we need to import these Java libraries and all the classes created previously. So we import product class, product list generator class, and task class. Within the main class, add these lines of code to create the object of the product list generator class, and to create a list of 10,000 products. Further, we create a new task object to update the prices of all the products in the list by adding this line of code. The parameter first takes the value 0, and the last parameter takes the value 10,000, that is the size of the product list. Also, create a ForkJoinPool object using the constructor without parameters with this line of code, executing the task in the pool using the execute method. Here, we created a ForkJoinPool object and a subclass of the ForkJoinTask class that we executed in the pool. Now, to create the ForkJoinPool object, we use the constructor without arguments, so it will be executed with its default configuration. When the ForkJoinPool object is created, those threads are created and they wait in the pool until some tasks arrive for their execution. Here, we sent a unique task to the pool to update all the lists of products using the execute method. In our case, it's an asynchronous call, and the main thread continues its execution. We include this code snippet. This part of the code displays the information about the evolution of the pool every 5 milliseconds, writing to the console the value of some parameters of the pool until the task finishes its execution. Enter this line of code to shut down the pool using the shutdown method. Here we check if the task has finished without errors with the isCompletedNormally method, and in that case, we write a message to the console. We include this block of code. Here, ifConditions checks that the expected price of all the products after the increment is 12. With this line of code, we write the name and price of all the products that have a price difference of 12 to check that all of them have increased their price correctly. Lastly, write a message to indicate the finalization of the program. Finally, like with the executor framework, you should finish ForkJoinPool using the shutdown method. Run the program and view the output on the console. You can see the tasks finishing their work and the price of the products updated. In this video, we used basic elements of the ForkJoin framework.